Welcome back. The ticket booking use case exposed a severe problem. The race condition, where multiple threads corrupt shared data. The solution is thread synchronization, which means coordinating the execution of multiple threads to ensure that when one thread is accessing a critical piece of data, no other thread may interfere. 1. The critical section. A critical section is any part of the code where shared resources, like variables or data structures, are accessed or modified. In the ticket use case, the critical section was the if block where we checked the ticket count and then decrement it. To prevent race conditions, we must ensure that only one thread can be inside this critical section at any given moment. This is called mutual exclusion. 2. Introducing the lock object. We have a simple synchronization primitive is the lock object from the threading module. A lock starts in an unlocked state. When a thread wants to enter a critical section, it calls lock.acquire parenthesis. If the lock is unlocked, the thread immediately enters and the lock becomes locked. If the lock is already locked by another thread, the calling thread is forced to wait until the lock is released. 3. Using the lock manually. The pattern for using a lock involves 3 parts. First, call lock.acquire parenthesis before the critical section. Second, execute the critical code. Third, call lock.release parenthesis after the critical code. It is a practice to wrap the critical section in a finally block. The finally block ensures that lock.release parenthesis is always called, even if an exception occurs inside the critical section, preventing a potential deadlock. To summarize, locks prevent race conditions by forcing threads to wait their turn. Our next lecture 26.11. Add more logic. See you there.